Hello, listeners, and welcome to Plugged In, the Energy News podcast from Montel, where we bring you the latest news, issues, and changes happening in the energy sector. The UK government wants to be one of the world leaders in nuclear. Italy has said it's ready to return to nuclear power and replace some of its renewable production. France's energy minister has expressed his priority to make nuclear power a strategic lever for a more sustainable, competitive, and resilient Europe. We've seen a flurry of announcements across Europe about what these nuclear ambitions will look like in practice. But these plans aren't all focused on large-scale nuclear that we've seen in years gone by. Which leads us to the question we'll be asking in today's episode. Are small modular reactors, also known as SMRs, going to be the way that European leaders will achieve their ambitions? In this episode, I will be speaking to Rolls Royce SMR, but first, I'm joined by our France editor, Chris Eales. Welcome back to the podcast, Chris.
Well, thank you, Richard, and hello.
Let's start off by looking at, why are we seeing an increase in plans for SMRs across Europe? It's become quite the hot topic, really, rather than large-scale nuclear. Why is that?
Well, SMRs, they promise a faster, smaller, modular deployments. So the idea that manufacturers, they're planning to serialize production. And the idea behind that is that with mass production, you reduce unit costs. Another aspect is the flexibility of these SMRs as compared to large-scale reactors. These could replace coal units, for example, supply district heating, industrials and data centers directly. The other aspect is the context. There's competition in China, Russia, and the US, and Europe is way behind in terms of developing SMRs. So governments are pushing, and the EU as well, to back these kind of programs in this context, with given that there are these promised benefits.
But they're still in their infancy, right? So I think both in terms of their concept and design. So has there been any skepticisms or concerns from some in the energy sector regarding the technology?
There's major and very serious concern about SMRs. Some analysts actually say that SMR costs are more expensive per megawatt hour than large reactors. And if you put renewables plus storage, so more expensive at the moment without this, there's no series effect. We talked earlier about the series effect. That's not happening anywhere in the world at the moment. So, and the costs of building a prototype in Europe and the industrial processes, which means building the reactors in factories and then producing the fuel for these reactors. A recent report in France, for example, the French regulator estimated it would be €1 billion per project for this prototype. But after that, you've got the costs of producing each reactor and the special fuel that's required. So nobody really knows the full costs of getting a prototype off the ground. And without that, there are difficulties. The projects need to get private finance to match public finance. This is very important in the United States, for example, where they have moved a step ahead. Private finance is matching public finance, but again, we're talking about at least $1 billion per project. So it's a huge demand, which is at the moment an investment that's regarded as too risky for private investors to enter alone. So yes, we have seen some projects have got venture capital funding, but to try to move them to the next stage. But we are a long way from that, and in fact, there was a recent report from critical of the nuclear industry called the World Nuclear Industry Status Report, which said the gap between the hype and the industrial reality has never stopped growing.
So I think it's safe to say, Chris, that without state support, these projects probably couldn't get off the ground. But
yes.
Thanks very much, Chris.
Thank you.
Well, I'm delighted to be joined by Head of Customer Engagement at Rolls Royce SMR, Sophie Macfarlane-Smith. A warm welcome to the podcast, Sophie.
Hi, Richard. Thank you very much for having me.
I'd like to really start off by asking what are SMRs and what's all the fuss about, really?
So SMRs cover a whole range of different technologies. So it's a catch-all term that's used for light water SMRs, like the type of product that Rolls-Royce SMR has, which is taking existing technology but delivering it to the market in a slightly different way as a modularized power station. But it also covers other more advanced nuclear technologies like molten salt reactors, high-temperature gas reactors, reactors like ours that have a high power output. We are 470 megawatts, right down to micro reactors that are a few kilowatts or a megawatt or two. So the term is used for a real wide range of applications and a different technology types. But we refer specifically to the SMR as a existing pressurized water reactor technology, but delivered as a complete power station in a modularized form. So when you think about all of the sort of other industries, oil and gas, construction, lots of industries have moved over the last couple of decades towards using modularization to increase efficiency of deployment and operation. And we're just taking those technologies and applying them to the nuclear sector.
Absolutely. So would you say, is it proven technology as it stands?
So definitely for a pressurized water reactor, we have the most used technology in the world today. For 60, 70 years, pressurized water reactors have been used around the world. Over 70% of all of the world's nuclear plant today are pressurized water reactor technology. We in the UK and we in Rolls Royce specifically, we have been designing, manufacturing and operating small pressurised water reactors on behalf of the British government and the defence programme for over 60 years. So we have a lot of heritage in that space, but so does the rest of the world. So it is definitely proven technology. In terms of the modularisation, the applications, the approach to modularisation is proven by other industries and has been proven by other industries for several decades. We're just translating that. So certainly the nuclear technology is proven, but also the modularization approach is proven in other industries.
And has an SMR been built anywhere in the world?
So yes, there are reactors that are classed as SMRs that have been built or are in construction. Primarily that's in Russia, China, but there are SMR programs in place and construction underway. So notably GE Vernova's project in Canada has been underway with OPG for the last couple of years. There's a project in Romania with the NuScale application that's underway. And obviously will soon begin construction in both the UK and the Czech Republic of our technology.
And we'll return to that very soon, Sophie. But it's certainly a very hot topic at the moment, and certainly, we hear and often it's in combination with data centers, the big tech, etc. But what are you hearing from sort of utilities and customers in regards to SMRs? Where are you seeing the biggest sort of demand centers in Europe, particularly?
I've lost count of the number of applications. Every time I think we've come to the end of the number of customers or potential customers for a nuclear plant, someone else comes along and says, "Oh, actually, you're applicable to us." The nuclear technology is just a big producer of electricity or steam. So huge amounts of industry either need electricity or steam or both. And the type of and generally industrial applications need always on available 24/7 available electricity or steam. And that's what we can provide. So we are definitely talking about providing electricity to the grid, to consumers, to decarbonize the grid and provide stability as a replacement for other baseload applications, but also obviously data data centers, again, they want to use as much low carbon energy as possible, and they need it always to be available. So again, there's a huge demand coming from data centers, specifically for both the training of AI, but then also the usage of AI. And that is focused on certain hubs in certain countries around Europe, but then industrial applications. Again, there's a huge industrial sector that's spread quite widely across Europe. So we see slightly different applications in different parts of Europe. Certainly, there's a huge push for replacement for coal plants in certain parts of Europe, and that's a real high application. And then in other parts of Europe, it's around data centers and pharmaceutical industries, other sorts of industries, pharmacochemical industries rather, who actually are looking to decarbonise. But also the real push is around energy security. So again, having that energy independence and energy security in your country or in your region, actually, especially in these current times, is of high interest to governments.
Absolutely. I mean, could you talk us through kind of the economics of SMRs and why should countries opt or why should some companies or regions opt for building SMRs rather than large units, say up to 2 gigawatts or between 1 and 2 even?
Yeah, I mean, all different nuclear technologies have different applications. So all of them are completely valid and they work in combination with each other. So obviously, the large scale nuclear plants in countries like the UK, in other countries, obviously in the Czech Republic where we're working, in France, there is such an energy demand that those scale of nuclear plants are absolutely required. And the costs associated with those are managed as part of government infrastructure programs. That's perfectly appropriate. What we're trying to do at the SMR scale is actually say what we want to do is enable this technology to be financially viable for more customers than just governments. So obviously our technology is potentially suitable for governments, but actually we're talking about a price point that means that actually private companies, private industries can for the first time choose to support or purchase this technology for their own energy use as well. So we're opening up the market to a much wider range of customers because we're not talking about the tens of billions of pounds. We're talking about the low handful of billions of pounds in terms of an individual project. And that is something that actually from a data center company or an industrial company, that is actually a cost that they can see as economically viable going forward. The other approach we bring is obviously our type of technology is able to be deployed in many, many more locations. So we don't need to be in certain locations with access to certain amounts of water or various other things. The Rolls Royce SMR is specifically designed to be able to be deployed in very many locations. That means that actually we can be sited perhaps near to existing industrial facilities in a way that's not possible for a very large scale plant, just because of the size and scale that type of plant requires. So they're different for different applications.
So that's very interesting. So I think because you obviously you cited government deals with governments to build nuclear, but here you've got private companies or industries signing deals with builders such as yourself. Would that take the form of PPAs or long-term power contracts? How does it work in practice? I don't want to sort of open up the can of worms that is the contracts and everything. But how does that work? Sort of put quite sort of simply.
Yeah, so the market is still evolving, I would say. I think there's a huge amount of interest in nuclear technology by many industrial companies, data centers and others. They are trying to understand how they can get access to this power. So in general, I would say the majority of companies that we're talking to, and we work with other industrial groups, the majority of companies don't actually want to own a power station. That's not part of their business. That's not what they do today with their current existing power sources. That's not really what they want to do tomorrow. They want others to build and own and operate the plants for them, and then they can get access to the power. Now, there is a discussion around how can they incentivize others to build those power stations? So you may see different models coming forward, and certain models are suitable for some customers, and other customers want a different approach. I think what's very clear is there is still, unfortunately, a nervousness in the market in terms of how these projects will be built, but and the risks associated with the construction of nuclear plant. But as we move forward with our early projects and prove that we can do these plants, build these plants on time and on budget, then actually that concern will fall away, and we will start to see more companies actually feeling more confident to come forward. But really, I would say what everyone wants is access to the power. They want a plug that they can plug in, and they want someone else to just give them that black box of the power. But we will see different models in different places, I think.
I mean, as you mentioned earlier, you won the bids to build 3 SMRs in the UK and 6 in the Czech Republic. Can you give me an indication of how long it typically takes to build reactors of this size and get them connected to the grid? I mean, are we talking 5, 10 years? I mean, nuclear technology is notoriously there's lots of delays and cost overruns. Is that the case for SMRs potentially?
So it obviously depends. So our technology specifically, the Rolls Royce SMR, is designed specifically to reduce deployment risk. So our approach is to modularize the complete power station, and then we will manufacture most of those modules in factories, so we can quality assure them. We can make sure they can be manufactured to time and to budget in those facilities, and then those modules will be transported to site. So we are going to be deploying these nuclear plants in quite a different way that's been seen before. And that's deliberately done to reduce risk and reduce lead time and increase certainty. And there's lots of other things I can talk about that we're doing specifically to reduce lead time. But if we talk about timescales in detail, what we are targeting is an on-site construction period of around 4.5 to 5 years. Now, we're obviously assuming that the first ones that we do are going to take a little bit longer, but it's around 4.5 to 5 years. There will be some manufacturing up front of that, but then also there will be the planning and consenting processes and the licensing process. Now, in many cases, including in the UK, that process currently tends to take longer than actually the manufacturing and construction of the plant. So we can only go as fast as the planning consent allows us to go. Now, lots of governments, including the British government, are working on how they can accelerate that process, how they can reduce the time for planning and consenting. And we're actively involved in discussions with various governments around doing that. But obviously today we have to work within the legislation that is currently in place, and we're obviously planning for that. So again, our approach is to try and accelerate this, try and get down to a construction time of 4.5 to 5 years on site. But obviously, we have to make sure that the planning and consenting can go as fast as we can go.
And they can be done currently, so you can build 5 or 6 at the same time. It potentially, theoretically, I'm not, but
absolutely right. So the big question that we have at the moment is how many can we sensibly build at the same time? Now, it's really important for us, given our heritage as a manufacturer globally, we know how we have to control what we're doing very carefully. So in the early days, we are absolutely not going to take on more than we believe we can successfully deliver, because it's really important that we get this right. We're talking about very high quality components, a very strictly controlled process here. So we have to make sure we're doing this correctly. So we are preparing at the moment to deliver 2 or 3 concurrent programs in different countries. And that's the build out that we have at the moment. And we are looking at how we can sensibly and safely accelerate beyond that to do more at any one time. But obviously we can only go as fast as the capacity allows within the supply chain as well. So we have to have a very measured approach with our partners to say, okay, how can we sensibly build this out across the region? And it's really important that we do that. If we try and move too quickly, there's the issue that we could then make mistakes, lose control, and that's not in the interest of anyone, and certainly not in the interest of our customers. So we've got to do this in a very measured way.
Absolutely. And I'd like to ask you about regulatory approval. Where are you currently in the process in
So
the UK?
we have been working. We are currently going through the UK's generic design assessment process. We're very fortunate to be doing that because the UK allows us to create a generic site. In effect, we make up a site with all sorts of conditions you would never see in real life, which means that at the moment, in effect, the regulator is assessing us against conditions that we might see in many, many different places, certainly across Europe, but also around the world, which means that we're testing that our plant is suitable for all of those different types of conditions, which is really helpful when we want to deploy in multiple places because that's already been looked at. So we are now in step 3 of the generic design assessment in the UK. That's due to finish in the next year or so. Again, the final stage is a consultationary, so it's not really within our gift in terms of when they finish. But within the next year or so, we should have completed. And really importantly, we finished step 2, which is where the regulator has said that they see no fundamental issue with our design approach, which is absolutely brilliant. We obviously have the job of work now to prove that with all the evidence we're providing to them. But we're really well progressed in the UK. And obviously, we will move then, once we move into the GBEN programme, we'll move into site-specific licensing straight away. The other thing that we've been doing is since the step 2 of the generic design assessment, we've been working very closely with other regulators across Europe and now in the US as well. So certainly the regulators across Europe have been watching us, have been observers to our GDA process. So they've been actively involved watching the meetings we have with the British regulator, getting the information as far as is allowed via export licenses, and having the opportunity to ask questions early to say what they like, what they don't like, any specific feedback on the design. So we've had the opportunity to get that feedback at the design stage and make any changes if necessary. And you would not believe the issue around fire doors in different, forget nuclear regulation, which is obviously complicated, but some of the non-nuclear regulations, the requirements for different size fire doors in different countries across the world is just phenomenally complicated. So we're finding all of those things now, and we've got the opportunity to fix those things. But then also we have entered the process in the US as well. So we have started engagement with the US regulator, the NRC, and we're in the early stages of looking at licensing in that country as well.
How do the regulators compare? Are some more stringent than others? Or is that, or is you say the issue of fire doors? Obviously the devil is in the detail here,
it is.
But are some more stringent than others?
So I would say all regulators are stringent, and they are all stringent in their own particular way. I think what's really helpful is all of the regulators we work with are really keen to collaborate. So they all want to, quite rightly, preserve their national sovereignty. They want to properly, on behalf of their population, they want to be able to independently check that what is going to be deployed in their country is suitable for their country. And that's perfectly right and proper. And that's really important for public acceptability wherever we go in the world. But also what they want to do is collaborate. So where one regulator has assessed a technology, has done some independent work to assess maybe some evidence that has been provided, the other regulators don't necessarily want to redo that work unless they see that there's a need to. So what they are looking at doing is saying, well, actually, if you've already agreed to something, let me understand how you've done that. Let me check that that is also appropriate for my regulation, which in some cases it is, in some cases it isn't. But where it is appropriate, there is a question about whether that work needs to be redone or whether they can reuse what's already been put in place. And regulators are really keen to do that. So they avoid duplication of effort. They try and make sure that they only look at new regulation where it's absolutely required. And that's really sensible. So we obviously, all the regulators, including and ourselves, the technology vendors and others, are looking at how regulation could be harmonized in the future, which is brilliant, like the aerospace industry, where there's a couple of regulators in the world and everyone follows the same. hopefully in due course we may get close to that around the world, but we don't expect that in the next 5 to 10 years. But what regulators are doing is being really pragmatic, really sensible about trying to learn from each other and accelerate the process where it's sensible. And they are absolutely great at doing that, or certainly have been with us, which is brilliant.
I think it's around issues of national sovereignty, isn't it, as well, where people want to decide themselves what's right for their national demand for electricity, whatever. But so what you're saying is that if a design receives regulatory approval in one country, it doesn't necessarily mean it can be the same in another.
No, absolutely not.
No. You need to go through the same process from scratch again, almost.
Absolutely. In principle, we have to go through the same process from scratch. But what we are doing is already engaging with those other regulators early to make sure we can make sure they understand the technology. They can let us know any concerns. We can be very clear what they like, what they don't like. So far, we've been very lucky. Most regulators say our technology is boring, which is brilliant from a nuclear perspective. Boring is good. So we are deliberately designed to be as low risk in regulation as possible. So really boring from a regulator perspective.
Yeah, boring is good. Yeah.
Boring is good when it comes to nuclear. So that's what we've done. But you discuss early, you make everything open, you share what's been done. And the British regulator is brilliant at that as well in terms of helping us explain our technology. In an ideal world, of course, if one regulator approved it and others just accepted, that would make our lives so much easier. But we know that's not the case at the moment. So what we are doing is working in collaboration to say, let's talk to each other, let's understand, let's move forward. And that is helping us to accelerate deployment. But it's quite right that the population of any country should be reassured that their own regulator has independently assessed what they're receiving. That's only fair. That's what we would want. That's what I would want.
Absolutely.
So I think that's only fair and right.
Very much so. So I'd just like to ask a couple of questions about the place of SMRs and nuclear, maybe even in the wholesale market. Now we're in the middle of rapidly changing our energy systems to a much more greener, cleaner electricity market. How do SMRs coexist with a very much renewable based system as well, where it's very intermittent, it's very volatile, when for example on very windy days, or there's a huge volatility in terms of energy production. How do SMRs fit in there?
So I think I'm going to call us boring again. I'm afraid we have the ability to provide that boring baseload, that stable baseload that underpins the whole energy system. So at the moment, obviously, that's provided by coal and gas. Actually, that can be provided by nuclear. So not just in terms of the high volumes of power that are required, but the absolute stability of that power. So we have availability factors of up to 95%. So in effect, that means consumers can always see that they will have that baseload power there in the grid or for their industrial application, and they can have that with certainty. So it's really important that we obviously have the wind and the solar, because absolutely to decarbonize we need every form of low carbon power that's out there. We provide a base load, and also in terms of for example, when there is additional capacity coming from wind and solar, the power that comes from us can be diverted to produce something else. So hydrogen, to produce synthetic aviation fuel, for all sorts of other applications. We can be switched from one application to another, particularly applications that need steam as well as electricity. We can switch and actually, for example, produce hydrogen while the grid is being filled with solar and wind. We can be used for something else. Obviously, there is the option to use to in effect turn off the nuclear power plants, to turn them down, to have them producing lower amounts. But to be honest, that's not necessarily the most economic approach. approach where what we produce could be switched to other applications. And then if there's an issue with solar and wind, then we can be diverted back to the grid. So we are a really flexible baseload solution that we think complements renewables incredibly well and provides that baseload stability.
Absolutely, and as you mentioned, also it provides the energy security that But Sophie, a final question, really. We've seen, as summers are getting hotter. There's heat waves, there's droughts, and we've seen how that affects some nuclear plants in certain parts of Europe. For example, in France, with having a lot of cooling issues. How is this an issue for SMRs, like the cooling?
So it's an issue with respect to water availability. So it's one of the advantages of SMRs, and particularly the SMRs, our SMR, the Rolls Royce SMR, because we are designed to require a much lower volume of water in normal operation, and we are designed to have different cooling water solutions. So depending on where we are geographically, physically, we don't actually have to be near large bodies of water. We don't need that. We actually have other module cooling solutions, air cooling, that mean that we need a much lower volume of water. So we certainly need a volume of water, but it's much lower than would be required by a large nuclear plant. So actually, we are not so subject to issues relating to water availability. Now, we are not immune to issues relating to water availability. There is still a certain envelope that we are required to be to operate within, but we are designed to be more future-proof. I think one of the issues with existing nuclear plants, obviously they were designed and constructed many, many years ago in the 60s or in the 80s, where perhaps some of these things weren't such an issue or weren't foreseen to be an issue. And therefore now they are suffering from problems that weren't foreseen in the past, where quite rightly our regulators and ourselves, we require ourselves to design looking at what may happen in the future, particularly with climate change. So we are more immune from those issues, but I wouldn't say we're totally immune. That it would be wrong of me to predict that.
Sophie, thank you very much indeed for being a guest on the Plugged In Montel Energy News podcast. Thank you.
It's been my absolute pleasure. Thank you very much.
It's been an excellent and insightful discussion. I hope you agree, listeners. And thank you for tuning in to this episode. Our podcast episodes are released every Friday. For the latest news from Montel, please visit montelnews.com, and you can follow us on LinkedIn, Blue Sky, and other social media channels. See you next time.